All right. I think we are live again. And I am going to continue the project that I was starting yesterday. I have linked the project page down. I can't do that. Down in the right-hand side of your screen. I've sent a link, so if if you before you ask, just check there. Uh, and what we're doing is we are probably finalizing that I2C RGB LED board that I was starting yesterday from scratch as a KiCAD project. Uh, Let me just do a small recap. Start by looking at the schematic. For this project, there is a header where you can connect power supply, VCC, and uh, I2C, and a reset pin. So you can reset this device if something goes wrong. I have never actually seen anything go wrong while it was running, but you can do that. Um, you then speak directly into this I2C LED controller IC called AW9523, and that one will then be driving 5 RGB LEDs, which is the maximum. It will have one spare pin, so well, we could put one more LED on the board, but let's not bother with that. Uh, Since yesterday, I have made a few changes. Somebody pointed out in a comment, and I actually noticed that myself, that I accidentally, when I started putting components on this board, I used a 20 mil, but normally I will switch between a 20 mil. I have those configured. Let me show you that in my preferences. Grids there. You have these two hotkeys. You can switch between L1 and L2, which will switch between two grid settings. Um, and that is quite convenient. But I accidentally started this with 20, so I have realigned everything so it is actually aligned. Everything is now aligned with this grid, including all the components. So that should be much better. And the border edges, I also got that wrong yesterday. So that's pretty much it. Yesterday we did switch to a 4-layer board, and I will have the ground layer is here. I will have a ground fill on, no, that is VCC layer, which is int1, the internal one layer. I will have the power supply there, and then on all the other layers, the top and the bottom and the int2, I will have a ground fill. It should give a pretty good ground plane, I think. Other than that, I have made one change, I think only since yesterday. I have actually, if we go and view the 3D viewer, I made my own footprint for the LEDs, and I found a 3D model for that LED. I didn't make it, I found it, and I can show you briefly what tool I used to do this. So I installed Easy EDA to KiCAD. If you run that LCSC ID, you can simply give it the ID of the component. So if I look at the LED, I used that LCSC ID. So if you go down here, you can run it like that and say I want the 3D model. And if at all it is available, it will then go on and it will download a step file that it will put in a particular folder, and you can simply take that step file and add it. Let me show you how to do that. That was in the footprint editor. I created my own footprint here. Wait, we recommend. Oh, I think I should run a bigger, faster bitrate. Let me know what you think. I'm streaming in too low a bitrate, I think. So anyway, to see that, I have it here, and RGB I called it. If you go into footprint properties and go to the 3D model, you can add a 3D model in here, and you just point to that. I put it into the library folder and then simply link to that, and it will show it in here. One thing I noticed still is, I think that was done with that. We're not going to make any changes. Go back into the PCB. I thought I did that yesterday, but let's look at the physical stack up. No, I did make it 1.2 millimeter. So that should be more than enough. So 1.2 millimeter 4-layer board. All the components are now aligned with the grid proper. Let's try to move that one. Yeah, all are aligned proper. So that is about it there. Now, there's one change I want to make, and before I go any further, so let's over in the schematic editor. Now, yesterday, according to the datasheet, you should address 0 and 1 should be tied to VCC if you want to use LED drive. Otherwise, there may be a glitch when you start it up. But it would be cool to be able to run more than one board of these. So I want to make this address at least partly configurable. And the easiest way to do that would be to remove this, make a little change in the, and remove that, and then what I will do is I'll put a label here. We'll call it add 0. I press R to rotate, and I put that there, and then I'll do an AD1, rotate twice, and put it there. So now I have a labeled net, and down here we can actually add some solder jumpers. Let's see if we can find a good looking solder jumper. You have here, I want a 3 solder jumper bridged 1, 2. So that will look somewhat like that. It's solder jumper 3, bridge 1, 2, 3. Yeah, this one will do just nicely. And I think we'll simply do it like that. Edit that. There is no need to have a value. Sorry, we can leave the value, but I don't want to show it. I don't need that. So like that, and I think we need to flip that like that. So if we duplicate is Control D. So I'll duplicate this one, put it here, drag it down a little, and then I'll need the VCC, duplicate that, and put that there, and drag it up a little bit, and then I will duplicate this one. That should do the trick. So now 80 will go to the solder jumper, which will then be default connected up to VCC. I will need to put a footprint on this one. So let me go in and pick a footprint for that. Jumper. That's a new. Why? Footprint. I think there is down jumper here, jumper solder jumper 3, solder jumper 3 with 2 breads. Well, that will actually do fine. It's a oh, let's go with something like that. That looks okay. So now I can duplicate that one, put it there, and duplicate that one. Duplicate that one. Duplicate that one. And duplicate that one. So that's pretty much it. So address 0 and address 1 will now go to these solder jumpers that by default go up to VCC, but you can cut that and make a short on the solder jumper down here. And that is pretty much it. Let's save that and let's update the PCB with those changes. So we now have those 2 solder jumpers. And the solder jumpers, I will flip to the back side of the board. There is no need to have those in, and then move this one. Well, let's see, we have, so that will be the top one. I think we'll just put it up. And move that one over there. I think we'll do nicely. Nope, can't have those. No conflict with that. I need to put it down there if we want to keep using those. Let's see how that looks in the 3D viewer. Wait, this irritates me. Let's fix this little problem down here. The capacitor is, you can see that little red line. If I move that, it should be over there. All right. Let's view the 3D viewer. That looks much better. And let's look at the back side. Look. I think it's because I didn't. If you press B, you recreate those fill zones. I think that was the problem there. Let's look at the 3D view again and look at the backside. Yeah, that looks much better. So, in other words, it's possible to cut these lines and then make a solder bridge over here. It's relatively easy to make that change. Also, I don't want them. Let's update the let's update the. Can we actually just let me do an experiment? I don't know if this works. Why don't we call this? Why don't we label them? Add null AD. So if I can do that, that would be then I don't have to manually. So at 0, I label them. I update my PCB. Let's see if it actually updates. Yes, it does. So now, if I go into the address viewer, you can actually, it's labeled OK. Now, let me check another thing. I2C LED. Let's actually add a little silk screen on the. We go on the back silk screen and we add a text. And the text, we can simply use those meta variable. Work fine. So we can put that now. So view, 3D viewer. Oh, now it will actually have a label. We should also label. Let me do that while I'm at it. So we have those. Let me add. I'm still on the back silk screen. Let's do. I think we can do it here. So we call that VCC, and I want to align to the end there. Clock. Oh, we have a viewer got, so basically you're trying to arrange the element to minimize the trace footprint, but not really. I'm trying to make sure that nothing, not everything have to cross. I mean, it's basically, let me finish this before I forgot what I'm doing, and then I will, well, that will be a little SDA align to the end. Let's see if we can. And finally, RST. This is getting a little bit confusing. Oh. Should be there, and I think I can squeeze this one in. Squeeze this one in here, and finally, GND. We need to align it to the end, and let's Let's see how that looks. Actually, can't I rotate them the other way? If I edit that one, I make it center aligned, and then I move it, rotate that. Edit that one, center align, move, move. I think I can just exactly do that. So let's edit, center aligned. Wonder if there's a hotkey. There probably is, knowing KiCAD. KiCAD pretty much have hotkeys for everything, which is a royal pain in the ass when you are trying to learn something, but once you get used to it, it is really quite convenient. Let's see how that looks. Oh, it's running together a bit, but I can live with that. I could make them smaller. I sometimes do that. Should we do that? No, I can't be bothered. I think that's okay. So now we have pretty much all the components laid out, and we can start routing through this. Let's hope it doesn't get too bad. I think we will get away with it without too much problem. Now, when you are routing a board, I will always maintain, don't ever be afraid. Oh, we have somebody else. How is it so light outside in Germany? Well, that would be an assumption that I am in Germany. I'm absolutely not in Germany. I live in Malaysia, so Southeast Asia. It is now 8:20 in the morning. I think I started this stream as 8 o'clock, so I hope that answers your question. And was there another question you are trying to... Okay. Coffee. I had one more coffee earlier, so I could start this video. Yesterday I started without a cup of coffee. That was a mistake. Let's put it that way. So let's start, see if we can route this. Now, you may remember when I did the board setup that we have the design rule net classes here, and here I set some standard widths, and I usually set 6 mil, which is the smallest I'm using. I could technically go down to 4 mil, I think, but I'm using 6 mil, so I do 6, 9, 12, 15, and 18 mil trace widths, and unless it needs to carry power, I will default to using the 9 mil. I rarely use the 6 mil unless I absolutely have to. In the case of power, however, it's probably a good idea to go up at least to the 12 mil. So let's start by doing a trace. You're on the wrong side. Front, and we can route that down, and then one straight over there. I'm not going to do that one. I'm going to do that, I think, later. But this one we can run here. Let's. I think the most complicated is going to be that S at 0. So let me do that straight away. So this one needs to go to the pin on the back. So I will go out, I will place a wire. That will do nicely. And then I will go over to this. Right? And for the other one is down here. I can do exactly the same. So I start there. I put a wire. Well, that doesn't align quite as nice. Let me just check something. I found a setting yesterday that I enabled. I'm not sure. I think that confuses me. I prefer to control it myself. So I think that is what goes wrong there. I am in the 25 mil. So let's create the. Yeah, I think that's it. So that'll do fine. Actually, we have these VCCs just up. So no, let me change that one and say I want to go this way instead. I mean, there's absolutely nothing. There's absolutely nothing speed-wise. These are just preset when you start, so it doesn't really matter. But this means that I can go on my back and I can simply do a VCC up to there, and from this one, this one I can actually take it over there. So that routed that bit. Let me do the. Let me go to the 9 mil now. I should have done that, but let me hook up VCC to that one. I can't go bigger than 9 mil for these, and I should actually change this one to 9 mil as well, and this one to 9 mil, just because it fits. I have actually added a trace for the ground pins into the ground layer to get that one connected, but the pins themselves, if I do the flood fill, will be automatically connected on the top side. Now, do I dare to do this? Yeah, I think I do. One way of doing this, which is sometimes frowned upon, I can explain why, is to actually place a wire inside the ground pin. Now, the reason why that's frowned upon is that there will be solder paste placed on this pin, and that can the wire can act like a wick and actually suck all that solder out of there. So you need to use something called capped to do this reliably. So actually, yeah, I'm not going to do it because I'm not going to do with those. And I mean, it does get connected via the, here you can see the ground comes in and the ground comes in here. What I'll do instead is I will place a a ground wire there. I wouldn't. Deal with that later once I'm done with the routing. So these ground are okay. So the SCL, let's route the SCL. We'll go straight into that one. We are at 9 mil, and then it needs to go from there over to that pin. That works fine. The SDA, we can, looks better if I go that way. And let me make one change here. Let me make a bit more space, so that you have to keep that in mind, so that the ground fill actually gets in around. Otherwise there will be a green hole like that up. I don't like that. So let's back. So SDA needs to go straight in there. So let me mention that briefly. Does the wire go through the board? Yes, it goes through all the layers. Let's see if... And unless you, I mean, you have something called blind wires, which only connects two layers of the 4, but normally PCB wire images layers, can't we get here is a good example of it, right? You will have a wire can go through the board and connect multiple layers. In this case, we only have this option, so it basically connects to all the layers, but it can connect 2 layers still, but the whole goes through, but it doesn't. There could be spacing. Let's see if I can illustrate that. So this VCC should not be connected on the top layer where we have, remember, we have the float fill. So you will see the float fill, which is that brownish thingy, will not connect to this. So it'll make a nice space around it. Similar on the back side, the ground is not connected to this, but if we go into the one layer, it is actually connected. It is not spaced. It doesn't look like connected, but it is. You can see over here it gets black if it's not connected at all. So it is connected to the ground layer VCC and none of the other layers. You'll just have a spacing around it. And that is about it. I think that answered the wire question. Let's go back to our routing. Again, when I'm routing, it gets confusing with that. One of the confusing things when you start is the fact that you see multiple layers at the same time. You will see the blue layer is the background and the red layer is the front ground. So reset needs to go to that, and to that. I think we just wrap that directly. So there, it will go there, and it will, I think we go the other way. Reset, we'll go down there. So that pretty much take care of the left side of the board. Everything is connected. So now let's start. Let's start on the LEDs, which I think is pretty much all we have left are all the LEDs. I've done one up here, and again, let me make a little more spacing. I would like to get ground in. Let's try to do the flood fill there and see how that looks. Very nice. I don't think I can get it through there, so that is not an option. We'll stick with that for now. Let's see if we can route the others. So okay, I don't have VCC, so what I'm going to do with these LEDs is that for each and every one of them, I will simply flip to my rough. Oops. And I will do a wire there. So this one will simply go out and pick the stuff up. I can do that with this one as well. So there and there. Let's see how the routing goes with this one. This one will go there. This one will go there. And that one. Oh, that's right. That one goes to the completely other side. We'll do that last. So let's see this one. We go that way, right? And this one will go this way. That's good. Let's see. Let's try the others. So let's do another one here and flip rough and put a wire there. This one, let me do those straight away. While I'm at it, you see there was one missing here. We might as well just yank that into that wire. So it's all connected, so now we just have the data signals to deal with. I think this one goes there. I think this one goes there, and this one goes there. Oh, now we have a problem. Okay, I changed my mind again. Let's do that ground in there that I talked against. Let's just do it and see if it works. I think that will be okay. If I am not mistaken, let me just verify this. What happens is it will probably touch, but where is here? If I go into the footprint editor of this one, my component, and look at the paste, you can see that the paste is actually, it's not that component. AV, this is a new, I don't know, I have to look that up. Let's okay, that's a new one. I have never seen that before. Failed to find match for this regular. No error. AV9. And why can't it find it? Mysterious. Let's do something else then. Let's go back to this, like edit. Ah, there you can actually see it. And see the solar paste pads are. No, actually, I don't think it will be in the pads. It's actually not where there's any solar paste. It will probably run in there anyway. But I think we'll get away with this. So let's leave that and see if we can get this routed up. And I think this one is straightforward. So this one goes straight up. This one there, and this one we go the long way around. No, it goes this way. That's nicely. So here we do that one. I don't like that. That's nice. That's the last one we have. So the only way we can get that in is by going down here and put a wire. And then we need to get all the way up there, which will be absolutely no problem. We need another wire up here. Don't know why it left that one. Okay. So this is pretty much all she wrote. Let's do a design rule checker on this one. Oh, there's a bunch of questions. I can't see the questions, sorry. Is the big square round connected to a ground layer? I assume you mean the center pad of the AW9523. If you look at the schematic, it doesn't say so. But yes, if you look then at the library symbol, probably. There. You can see there's a hidden pin down here, pin 25, which is the center pin. So yes, it should be connected to ground on the center. And that is why on the board here, I will put that wire inside the ground to connect that down to the ground layer or the back side. It will go through, if we look at the 3D viewer, it will go through, and you can see here clearly that the cover is connected, but it's not connected there because that signal pin, but it is connected to this one. So it will get ground up that one, but unless I screwed that up, you also have ground coming in here to this pin directly. I probably need a ground pin over here. Let's do that. So we have ground here just to make sure that this one is well connected. Let's do a ground pin there. Right, so this one will have a very short path down to a good ground. What was the next? Is the big square ground? Is an AV. Look at the link. It is first in the comment. There's a data sheet. It is a micro. It's a LED driver. It's a GPIO expander and a LED driver. It drives the LEDs directly. I check your link and see that you are working on. Yes. Thank you. Okay, you got it already. So yes, it is also pretty clear from the schematics, right, that we have it drives so 15 LEDs, right? So 5 times 3. LEDs will be driven by the I/O pins of this one with one I to C hooked up to a microcontroller, and you just basically speak to it. So, save. I didn't really want to close that, but I ended up doing so. Uh, so actually, I think this is pretty much it. Now it's just filling around. Let's actually go back to this one. Now, I have a great deal of obsessive compulsory thought. I cannot take this. So I'll center the schematics nicely. Doesn't change anything, but it just looks better. So am I happy with the schematics? Let me just think through this. So I have the VCC with some decoupling of 1 microfarad and a 10 microfarad. I have pull-up on the 1K pull-up on the I to C lines. I'm happy with that. I have a somewhat slower pull-up on the reset in order to... So when this starts up, this point will be at ground potential, and then you get VCC on. It will be charged through this resistor, and it will come up slowly, and that will delay the startup of the AW9523. There is a comment, I showed that in the last video, there is a comment in the datasheet that it should be delayed. The reset should come after the VCC is on, so it's just to live up to that. I have already thought through the address selection. It is default to the default setting. Yes, it is. And all the LEDs are pretty obviously hooked up correctly. So yeah, I'm happy with the schematic. So let's go in here. I'm also relatively happy with this. I am sure there will be some mistakes, but let's try to run the design rule checker. Design rule checker will check violations, unconnected tracks, etc. Always run. It's not bulletproof. So there is an error, and that is a silk screen overlap, and that happens where? Over here. So yeah, it's those labels on the back. Unless we make them smaller, that cannot be. So I'll exclude that one, and I just tolerate it. And so 0 errors, 0 warnings, it's actually done. So now what we can do is a bit of fine-tuning. Oh, this is going to be a much shorter stream than yesterday. And let's think through if there's anything we can optimize. I tend to find a lot of the optimizations in the 3D view. Oh, yep, I see a problem, right? Because of this, these are so close to the edge. We don't have ground fill at all over here. I also want a ground fill in there. So let's start by doing those. I need a couple of wires. Where the hell was it? Viewer, it is at the top of R2, which is here. It's because we got that fat thing there. Again, there is absolutely no speed involved in the address selection line. So what I can do is I can go higher with that one. That didn't look very good. There. And then I should be able to put a... Didn't like that. Still not far enough. Let's switch to the fine. Oh, there should be space. Ground. So now I have a ground pin in there. Let's try to fill it. And look at the 3D viewer. I could put this down below, but I don't want to do that. So it is actually this one that we need to get up. So it is in here we need. So actually that one was wasted effort. Let's move that out of the way and let's see if we can squeeze one in now. Ground. Fill. Oh, that's better. So now we have a ground fill in here. Remember, it would be obvious to put it roughly there, but I can't do that because I got something on the backside. So let's not bother with that. I can live with this one. So now we just need a few extra ground wires at obvious locations. Let's do one there where we have, I mean, keep in mind always that wires are essentially free. So there. Let's put one up here. They don't cost anything, so be generous. There's usually no problem. They can be in the way when you're routing, so I would usually do that last. Let's see my 3D viewer. This looks ugly. How does that? Could make a little more space down there, and so oops. Switch to fine. We could something like that, and then we could probably fit a wire in there. There. Let's do a fill. View, 3D viewer. It looks okay. But yeah, I'm fairly happy with this. What was the reason we? Let me. That's actually irritating. So let me. I don't like that. And up here we were a little bit close. See if we can do both. Front. Well, the result is we don't get a fill in here. I don't care. What we'll do is more questions. Why did you add the additional ground via? Well, it's all about connection, right? Over here we have a ground pin. We have two ground pins. We have one there and one there. Because it gets a little busy over here because of that LED, I can't really squeeze a ground wire in over here. I could probably, but I won't. That means that the only ground is that little skinny one that comes down here, and I like a little more ground, so why not put a ground in the center that will then connect to the ground pin. It just makes it better grounded, that is all, and that is a pretty important thing. Is this board almost done? I can twiddle around with this stuff forever. Absolutely no problem. Let me see what I am contemplating. Actually moving these 100 mil out, or 25 mil out, to get me a little more space in here. I could also, but I can't be bothered, move that one a little bit to the left here. That would also give me more space. And these are the things, like, now, if this had been a production board, I would probably do this thing. One of my arguments that I always say, don't be afraid of ripping traces up and reroute it. As you can see, once you got the components placed and you're happy with the layout, the routing is the quickest part at all. It basically, the only thing that takes a little time is to make sure that your ground fills and all that is, I just saw an improvement here. If I push this up a little, like that, then you will see that the ground actually connects. Be careful with those islands that are not connected or not well connected. Now, there is nothing high speed in any of this. The only thing that is a little speed critical in this board at all, and that is not even speed critical, would be the I to C lines here. But you can see they follow a fairly straight. I would have considered maybe going that way around for this one, because then I would get the ground connected proper. It is blocked because the trays go through the pins of that resistor, but no, I cannot be bothered. Looks like, nope, we don't have an island. Can we do something up here to avoid that one? Not sure if we can. I don't think we can. Nope. Nope. I'm okay. Let's leave it. So I think it's time for me to talk about one of my. Oh no, I just found something I want to do. Just because it looks so much better. So if we look at the edge cut layer, which is this one, I will pull those back, and then where is the edge cuts there, and I will do a semicircle. So there we start there and go there. I round the corners. It just looks better. Takes a little time, but let's move those back. Let's move that back. Let's do the edge cut. Dun, dun, dun. Remember to go anti-clockwise. So I have to start down there and go up there, otherwise it'll do the semicircle the other way around. So pull that back, and there. I need to start there and go down. Let's try to press B to recalculate the float fill, and let's view in the 3D viewer. See, that is so much nicer that you have nicely rounded corners. So I have a label on the board, I have a revision on the board, I have these that I can reconfigure the address if need be. I have labels that are at least readable. Could we do something clever with that? Let me this is, to me, by the way, this is the most enjoyable part. When you have a board that you kind of done with and all you do is little improvements. And I actually find that it's quite relaxing. See, you can orient. Now, what if we say 110? That would be the wrong way, isn't it? Let me look at how that looks. Yep, I wanted to go the other way. So 90. So 90 minus, so 70. Let's try that and see how that. Now, I actually think I can make them not overlap if I do that with all of them. Wasn't that wrong in the first place? That's a bit weird. Let's try the next one. Let's see how it looks. So the next one is there. Let's do. Oh, that's weird. It was actually a minus. So let's say minus 70. I didn't notice that. Probably you should avoid placing silkscreen over wires. No, absolutely not. Why? They are filled with, they are completely covered with the solder mask anyway. So it doesn't matter. It can sometimes make it a little bit hard to read. But there is absolutely no problem in pasting silkscreen over a wire. Unless you want to use them as test points. You see, that one didn't work. So that's because I need to move that. I'll still overlap a bit, but it will be easier to read, I think. Do I want to finish this or? Nah, I can't bother. It actually, well, okay, no, I can't. This was a bad idea. So let's go back to the original. But I think one of them is upside down though. They read from that side, clock, STA, RST. I could make the font slightly smaller, but this one, rotate, and move. There. Now they are the same. No, I'm reasonably happy. Probably, I don't know why you think via it's absolutely no problem. And besides, if you want silkscreen, that's almost impossible to achieve. But anyway, silkscreen can easily be read. There might be a little. If you look at it, it's actually, I think it's reasonably represented here. What happens with the wires is that they have solar mask. The solar mask is the green stuff, and that goes all, and The hole is really, really small. So yeah, what can happen is what you see here, that there is a little bit of it that has been cut off, but it is generally very, very readable, and I never bother with not placing. You could also consider making a larger footprint. Yeah, I could consider that. However, I have done enough of these boards to know a few things. First of all, it is possible to hand solder these because there is a cutout in the component. Second, I'm not going to hand solder it under any circumstances. And the problem is, there is a very good reason. If you look at let's find that. If you go back and look at the wiki page, I linked this one at the moment. If we look at the data sheet, the manufacturer of the component will have an recommended typically at the end of the sheet. And now I'm an idiot because I'm looking at the wrong component. It was this one we were actually going to look at. Back down. I know where it is. It is at the end. Somewhere. All Chinese, but they do have here. Right. They have the dimension drawing, they have the pads, and this is the recommended soldering pattern. They call it footprint pattern. Yeah. Experience have taught me to follow that advice, because if you don't follow that advice, what will happen if you make the pads a lot bigger is that the components tend to float, and that means they align poorly. They could skew, and it could go wrong. And if it goes wrong, it is my problem unless I follow the advice of the manufacturer, in which case it is the PCB manufacturer's problem. So I generally tend to follow these almost religiously, and not use bigger footprint unless I know it can work. In this case, you could extend it a little bit out to the side, would probably not be much of a problem. But again, I don't see any reason to do it. Case of hand soldering, yeah, I don't really care. And besides, because of this cutout, a very fine tipped iron, I can still heat these up. It's not a problem. So yeah, I wouldn't actually make them bigger. I will follow the manufacturer's advice to the point. Is it possible to design PCBs for freelance work? I don't know. I never done any paid. I don't think I've been paid to do freelance PCBs. I would be very reluctant to do it because PCBs tend to be a fiddly process. I mean, you run a order. If I order these on PCB Way or JLCPCB or whoever want to sponsor this, hint, hint, there is perhaps, this is a relatively simple board, but there is 1 or 2% chance that it doesn't work, that I made a screw up somewhere. I did design these footprints myself. I could have done it wrong. There's always a chance, and there can always be back and forth. So if I were to do it freelance, I would definitely insist on being paid by the hour, because it's absolutely impossible to predict, or very, very hard to predict. You need to leave a lot of room for mistakes, which are bound to happen. Mistakes happen when you do PCB work. This is a very, very simple board, but when you make a complicated board, it can get really tricky. Let me show you something actually. And especially, it gets even worse if you design the if you design the circuit at the same time. It's more realistic that there is a problem with the circuit. But if we look at this, one of the first PCBs I did that was my STM32 green pill board, and you can see that that has now gone through 4 revisions. That means revision 1, it's all explained here what revision 1 was 2020. I showed up like this. Revision B, don't know what the change was actually. I didn't. Oh, a few components. Yeah. Revision C, I flipped that one up and different. So, I mean, it goes through revisions because typically, I mean, when you get first version of a PCB, I would generally say if it can be brought to work, it's a success. By brought to work, meaning you might need to cut a trace, you might need to run a jumper wire or something like that. But at least if you do that and you can make it work, then you know what the problem was and you can easily fix that in revision B. So if it can be brought to work, another one I just saw, by the way, here, my ST-Link device also went through a number of revisions. Revision A, revision B. I'm actually at revision G now. One of the changes was that PC. Now I don't want to mention their name. The manufacturer I used for them used to have a minimum size of 20 millimeter. So I have to do a trick like this where I'm actually breaking the board out after I get it back. But they removed that limitation. So these days I think I just order it directly. That's pretty much it. Oh, that was the last question asked. So, yeah. I don't like that. Oh, that is the... Where was that? Two. So it's at 1 where it goes over. Is it here? It is. So let me change that. Nope, wrong side. Let me do something like that instead. And do my float fill and view. That looks better. Anything else? Why am I not going straight up here? Was there a reason for that? There might have been, but I'm happy with that. So I would say if I ordered this just now, I am 90% and 99% sure it'll work just fine. Biggest concerns? Unlike that, the ground that I couldn't squeeze one in here, that does annoy me a bit. I'm thinking if there is a easy way of doing that. Not without moving either that one a little to the left or that one a little to the right. Or rotating it. No, there is no easy way of doing that. So mostly happy with this one. No, what I was about to say before I interrupted myself. Now, this board is simple. My confidence level is high. But under normal circumstances, I have my own review rule, and that is essentially working in a review process that goes like this. When I'm done and I think okay, I'm done with it, I'll save it and I'll leave it until the next day. I won't touch it, I won't look at it for the rest of the day. And the next day I'll open it. And then I'll go through the process schematic. I'll look at the schematic. Are there room for improvements? Are there something I missed that? Or are there any changes? I'll make those changes if they're there, and then I'll review the PCB, and I will be quite anal, so to speak, to make sure that I should be able to. No. Okay, I'll be quite anal in the review and make sure that everything is to my liking. If there's any changes to be made, I will make those changes. Now, here's the rule. If I make even the slightest change on that review, I give it another day and I do that review one more time the following day. And I keep repeating that cycle until no changes are made. Once I'm happy no changes were made, I'll shoot the order out. And 99% of the cases, I'm okay. It can, at least, as I said, it can be brought to work somehow. So, why am I? This is no longer floating around. So that is actually silly what I'm doing there. Cancel. Let me go to the fine grid and let's. Why am I not? Doing like that instead. I'll look better. And no, won't make any difference. As I said, this is DC only, so there is no, yeah. Now here's another one. We can optimize a little. If we go up here, that looks like shit. That is better. Sometimes it doesn't get these things right. KiCAD. Let's remove the 2, that's why. And is there anything else that I could be doing here? So I keep flipping around between this view and the 3D viewer. The 3D viewer is, I'm catching surprisingly a lot of things that could be optimized on the 3D viewer. I don't like these overlapping. I'm probably going to fix that at some point. But no, so hook up I2C and you can drive these 5 LEDs in RGB color. D1, 2, 3, 4, 5. So, am I going to make another video in this series? Well, if I am, I don't really have any urgent. I might order this board, but I don't think I will, unless I actually approached yesterday. I sent a link to a few of the PCB manufacturers and assembly houses in China, and I showed them yesterday's stream. And I say, well, let me order this for free, and I will do a video about it. So I'll get back to you if they actually, if they show any interest in that. They bloody should, but let's see if they do. And if they do, I will actually, there's at least 2 more videos in this one, right? Because I'll do a video where I create the ordering files, and then I will do a video when I get it back. I'll probably do 2 videos when I get it back, because I'll do one where I review what I received back, and then I'll do I'll probably do a regular STM32 video where I actually program a library that can drive these LEDs. That is sort of the tentative plan, but I am also okay dropping this now. I mean, these days, as I mentioned in the first video, this is a somewhat pointless board, because these days you would use the intelligent, the NeoPixel board instead, which you can drive a 1 wire along string of them. You don't need this GPIO expander to run one of those, so it's easier, especially if you've got a lot of LEDs. So yeah, and they are almost as cheap as this one, if not cheaper. So I don't know if I should order this. It could also be that I ordered the other stream I did with the STM32 F402, and that might be another one that will be interesting to order, and I will go through that if I decide to do so. But I have not made that decision yet, and that is pretty much it. Guys, I would like your comments on the quality of this. I get a warning on my stream. This stream current bit rate, I set a bit rate in my streaming software, is lower than the recommended bit rate. So does this look like shit? If it looks like shit, I mean, I can't do higher resolution because I'm running my screen resolution, so that's pretty much it. So it's just the bitrate that YouTube is complaining that I am going too low. Let me know. You can put it as a comment if you like. Did you try the... Oh, there is a question I missed. Did you try the KiCAD plugin? No, I didn't. I have no idea what it is, and I generally tend to avoid plugins in no matter what I'm using. I'm avoiding plugins in Eclipse, in STM32, CubeIDE, avoid plugins in pretty much everything, because plugins can be nice, and then when you upgrade, they screw you. And I hate going through that process of trying to make everything work again. So if I don't absolutely desperately need a plugin, I'll just not do it. I'll not use them. And if it takes me a minute more to do it, I also tend to like doing things by myself. I get one of the most common complaints I see and questions I get about KiCAD or KiCAD is, oh, why doesn't it have an auto router? Well, it doesn't have an auto router because nobody professional would touch an auto router ever. Because as you can see from this video, the routing is by far the easiest bit. I could rip up the entire routing on this board right now and reroute the entire thing in less than 5 minutes. Probably 2-3 minutes. The routing is not a problem. What takes the time is the placement of the components. Where do you drag them around? Where do you place them? That takes an enormous amount of time. So, no, I don't use plugins. I actually think there is an auto router plugin that exists. I wouldn't touch it with a barge pole. KiCAD is an absolutely brilliant tool as it is, and it can easily do. If I have a complaint about KiCAD is that when it upgrades to a new version, they tend to do a lot of changes. If you saw, I think it was in my last video where I had some wires that they had some new features that I never seen before, and that confused me a bit until I learned to use these features. However, I'm not going to complain about that, because they obviously do that because they want to introduce new features. And I like new features. I like good stuff. There are tons of features I don't use in KiCAD, and well, maybe one day I'll start using them. I think one of my friends pointed out to me, let's see if I can make that work. And this is a feature I didn't know. So apparently if you want to group select, if you do it this way, if you do it the other way, yes, it's true. So this is actually an interesting feature. So if you go from left to right when you select, it will only select the components that are fully enclosed in the selection. So notice it doesn't actually select this one. It did select the pins though, but if you go the other way, it will select anything it touches. So these got selected, the entire components. So it matters if you drag that way or you drag that way. I think that's quite brilliant. It's just a feature. I didn't know it was there, and I never used it. And I have on occasion been irritated. Oh, it's really hard to select. But I think you can still do. Yeah, you can do Shift and then Shift click. You can select the components you want to select. So it is usually possible, but it's just a cool little feature. I'm sure when I started using KiCAD, it didn't exist, and it's something they added at some point, and I just never. I should probably make a habit out of reading the release notes. That would probably save me some time, but there you go. So yeah, this is typical ToCAD. I'm not sure what you're referring to, this typical ToCAD software. I don't know which. The selection, I didn't know that. It's been, okay, 35 years ago, I worked quite a lot with AutoCAD and 3D Studio, as it was called back then, but since then I haven't really done much in CAD software except PCB layout, which I started with Eagle, which I hate with a passion. I didn't like it back then. I like it even less now. Actually started back when I started with something called OrCAD back then. I can't remember what it's called now. It still exists to some degree, and that was poor. And then at some point I did a couple of hobby projects with Eagle, as I didn't like very much. And then one day I discovered that the step from Eagle to KiCAD, there was a learning curve, but once you got into it, It probably only took me a day or so to get into the groove with KiCad and or KiCad. And it's an amazing software package. It is the I know that Altium is probably have some features that are more advanced, but there's nothing I'm missing in KiCad. It does what I want, and it does it really, really well. And I have done a number of PCBs, and I'm quite happy with it. So that's about it. I don't think I can squeeze more out of this one. For the few viewers, I didn't have as many as I did yesterday, but that's fine. That's fine. I don't. I'll just. This is still very much an experiment. I want to see if I can get used to doing these live streams, and I am considering also doing some STM32 live stream. I don't know. If you look at the page, I will commit this to JIT so you can see what I have on that page I referred first. That one. There's a link to the GitHub repository. I'll throw everything in there and you can have a look at it if you want. And by all means, I'll leave this video up. I fully agree with you concerning, but I have a few that I can ruin. Round tracks and interactive HTML. Bomb, can't it actually generate that internally without a plugin? Well, the BOM I will usually export in comma-separated files because I'll upload it as part of the ordering process. It doesn't look good, but yeah, well, I have never needed it, but well, I also think, if I'm not mistaken, and that is actually an interesting thought, KiCad can have external plugins. That means you can actually operate via the KiCad API on files and projects in KiCad. And tools like that, I don't mind at all. What I dislike is the internal plugins because while they can be cool, they become an upgrade nightmare later, and I don't want to have to deal with that. So if I can at all avoid it, I will not use plugins ever. So that's about it. I am going to end this stream. Thank you very much to the viewers that hung on some to the entire end, I think, which is cool. I'm still learning how to do these streams, and I'll let you be the judge of whether it was worth it or not. So thank you very much, and bye. Have a wonderful rest of the day, and bye.